OpenAI today took a bold step toward owning its future infrastructure, announcing a multi-year strategic collaboration with Broadcom to jointly develop and deploy 10 gigawatts of custom AI accelerators. The move signals that OpenAI is no longer content to be purely a software and model house. It intends to control the hardware underpinnings of tomorrow's most advanced intelligence. The deal in a nutshell. At its core, the partnership divides responsibilities in a way that plays to each company's strengths. OpenAI will architect the chips, drawing on its deep experience training and deploying frontier models, while Broadcom will manufacture, integrate, and help deploy them. The announcement states that the racks outfitted with these custom accelerators will rely on Broadcom's Ethernet, optical, and PHY connectivity technologies for both scale-up, within a rack, and scale-out, across racks designs. The rollout is ambitious. The first hardware is slated to come online in the second half of 2026, with full deployment expected by end of 2029. This deal adds another string to OpenAI's compute bow. The company is already working with Nvidia and AMD for large GPU orders, but this partnership positions OpenAI to build a vertically integrated stack of model plus chip plus system. Why this announcement matters? 1. Vertical integration and deeper control. Historically, most AI companies rent or buy accelerators from third parties, like Nvidia, and focus on model development. By designing its own chips, OpenAI is signaling that it wants closer alignment between models and hardware. In principle, it can bake in custom data paths, communication topologies, memory hierarchies, sparsity support, quantization tactics, and more optimizations very specific to the models it runs. Moreover, controlling the hardware stack opens up advantages in negotiation, supply security, and cost structure. 2. Custom design informed by model experience. OpenAI's greatest asset in this venture is its hands-on experience. It knows how transformer models scale, where bottlenecks lie, how memory bandwidth versus latency trade-offs affect inference, etc. It can design chips that anticipate those constraints, something off-the-shelf accelerators might not do well. The promise is a hardware design that reflects real-world loads instead of theoretical benchmarks. 3. Network and systems integration at scale. A chip is only one piece of the puzzle. For the full system to deliver, interconnect and networking must scale too. That's where Broadcom's portfolio of Ethernet, optical, and PHY fabrics becomes critical. The design will enable both high-bandwidth intra-node communication and efficient inter-node scaling, necessary for sprawling AI clusters. OpenAI and Broadcom call out scale-up and scale-out networking as a guiding principle in designing the full rack architecture. 4. Competing with giants, Nvidia and company. OpenAI's move places it among the few AI players striving to break away from dependency on Nvidia, whose GPUs and interconnects like NVLink, InfiniBand, currently dominate the landscape. This also aligns OpenAI with cloud giants like Google and Amazon, which already develop their own AI silicon to manage margin, customization, and supply risk. That said, Nvidia's dominance is not to be underestimated. The new chips must not only match but ideally beat what is available off the shelf, on performance, efficiency, cost, yield, flexibility, software tooling, and ecosystem support. Potential upsides and strategic gains, cost efficiency and margins. At the scale of tens of gigawatts, small improvements in energy efficiency, utilization, cooling, and interconnect overhead can translate to billions saved over time. Running your own hardware stack gives freedom to push that margin envelope. Differentiation and lock-in. Custom architecture might become a competitive moat. Models that run optimally on OpenAI's chips may not run as efficiently elsewhere, giving it control over its AI platform and future expansion. flexible roadmap and adaptivity. With ownership over the hardware roadmap, OpenAI can pivot more rapidly in response to new model types, for example sparse models, quantization formats, new architectures. They are not beholden to external chip vendors' product cycles. Strategic leverage. Having its own silicon gives OpenAI bargaining power when negotiating cloud or hardware partnerships. It could conceivably license, integrate, or spin off portions of the stack if it proves novel or competitive. Supply stability and risk mitigation. The AI chip market is tight, and supply chain disruptions, fabrication, packaging, interposers, are real. By taking responsibility for design and partnering with Broadcom's manufacturing capabilities, OpenAI reduces exposure to being a guest buyer in a crowded market. Key risks, uncertainties and challenges. While the upside is compelling, the technical, financial, and strategic hurdles are formidable. Design and execution risk. Designing a leading-edge AI accelerator is no easy feat. Mistakes in timing, power management, thermal design, interconnects, routing, yield, or integration can severely degrade performance or delay deployment. Getting from design to silicon at scale is a well-known minefield. Ecosystem and flexibility constraints. AI models evolve rapidly. If OpenAI's hardware is too rigid or optimized only for present use cases, it may struggle to adapt to future innovations, for example new architectures, multimodal models, lower precision, sparsity, dynamic routing. Also, software tooling, compiler support, debugging, and driver stacks must mature. Manufacturing and supply chain complexity. Even if the design is sound, fabrication at leading nodes, for example 3 nanometers or beyond, requires third-party foundries, like TSMC. Additional dependencies, packaging, interposers, photonics, memory, testing, complicate scale. Coordination across this chain is non-trivial. Capital intensity and ROI uncertainty. Deploying 10 gigawatts of AI infrastructure is massively expensive, not just in chips, but cooling, power delivery, facilities integration, and operations. The return on that investment depends on high utilization, long life cycles, reliability, low failure rates, and scaling benefits. Competitive response. Nvidia, AMD, Intel, and other custom chip efforts won't stand still. They will respond with improved architectures, software stacks, integration, pricing, and partnerships, eroding any performance or margin advantage. The arms race in AI hardware is now well underway. Risk of overcommitment. OpenAI already has substantial commitments with Nvidia and AMD. Spreading resources and capital across 3 hardware domains is complex. There's risk in trying to manage too many parallel paths if one or more fail to deliver. Timeline and deployment overview. According to the announcement, design and prototyping phase currently underway, deployment begins, second half of 2026, full deployment completed, by late 2029, networking architecture, entire racks to use Broadcom's Ethernet, C, and optical portfolio, geographic footprint, deployed across OpenAI's own facilities and partner data centers. It's a multi-year, high-stakes build, with a clear target: get tens of gigawatts of custom compute capacity ready in time to power the most advanced models of the late 2020s. How this fits into OpenAI's broader compute strategy. This deal isn't happening in isolation. OpenAI has previously signed large-scale compute agreements. Nvidia, earlier this year, OpenAI committed to deploying 10 gigawatts of Nvidia systems, with Nvidia investing in and supplying infrastructure. AMD, another deal, provides 6 gigawatts of AMD GPUs, likely starting in 2026. Hence, OpenAI is not abandoning those partnerships. Instead, it appears to be diversifying and hedging its exposure while building internal capability. Moreover, OpenAI states that designing its own chips allows it to embed the insights from its model training and serving experience right into the silicon, closing the loop between model and hardware. In effect, OpenAI is trying to build a vertically integrated stack, models and GT, chip design and GT, systems and GT, deployment, with optional external partnerships sprinkled in. What it might mean for the AI hardware landscape. 1. Acceleration of custom silicon trend. The OpenAI Broadcom coalition reinforces the idea that large AI labs will increasingly design their own chips. Others, Google, Amazon, Meta, have already moved in this direction. This could shift the default paradigm from buy GPUs to co-design hardware. 2. Pressure on commodity GPU providers. If OpenAI's custom chips succeed in performance, margin, and flexibility, it could erode reliance on general-purpose AI accelerators. GPU companies might respond with more specialization, better margins, or tighter bundles. 3. Innovation in co-design tools and AMP chiplets. The complexity of designing full lifecycle AI chips may push development of new ADA tools, co-design flows, chiplet architectures, MEM-centric designs, and more modular silicon ecosystems. 4. Higher bar for new entrants. The barrier to entry in AI infrastructure may rise. Only organizations with deep model expertise and capital will justify custom hardware efforts. Smaller players may continue relying on third-party accelerators or specialized ASIC providers. 5. Fragmentation risk. As more AI labs build specialized chips, the ecosystem could splinter, models might be tuned to specific hardware stacks, tool chains may diverge, and portability could suffer. Interoperability may become a key challenge. Final thought, ambition meets execution. OpenAI's partnership with Broadcom is nothing short of audacious. It pushes the company further from its origins as a model and API provider into the domain of semiconductor design, systems engineering, and large-scale deployment. If successful, the payoff could be tremendous: lower cost per inference, tighter performance integration, and a lasting competitive moat. But the path is steep, silicon is unforgiving, and the market is ruthless. Only time will show whether OpenAI's custom accelerators can truly challenge the dominance of Nvidia and other incumbents. For now, this deal is a signal: the future of advanced intelligence is being built from the silicon up. If you found this video helpful, don't forget to like, subscribe, and hit the bell so you don't miss the next one.